Welcome to Woke Talk Podcast. I'm your host, Sam Stanford. As a physicist and structural engineering training with Jacobs Engineering, I have made many connections with some bright individuals who are either working, studying, or self-taught and passionate about our particular topics of discussion. Today's topic focuses on the colonization of Mars. We plan to uncover the challenges that lie ahead, some circulating ideas within the scientific community, and explore the beneficial possibilities of inhabitants. For anyone who is unfamiliar with Mars, you're in for a treat because the cast that we have today and myself plan to give a lot of insight into our solar system's fourth celestial planet. With that being said, I would like to now introduce my cast, starting with first, Gabriella Kizer. Gabby graduated from Slippery Rock University with degrees in chemistry and physics. Gabby was involved in multiple research projects at Slippery Rock University, with one in particular focusing on the contact binary comets of Ultima Thule. Our second guest was a former professor of mine that taught me thermophysics, Dr. Dustin Hemphill. Dustin graduated from Slippery Rock University with a bachelor's in computational physics and went on to Purdue to earn his master's in theoretical and mathematical physics. He continued on to get his PhD in physics and conducted 6 years of research with the High Energy Nuclear Theory Group, developing models of the Boltzmann transport equation, particle collision physics, and much more. And for those of you who tuned into our podcast last week on autonomous vehicles, you would be familiar with Dan Arnett. For the listeners who don't know Dan, he graduated with a bachelor's degree in computer science from Slippery Rock University, where he built their planetarium's projection system. Dan then achieved his master's in robotics systems development at Carnegie Mellon University, specializing in autonomous docking of planetary rovers. He used to work for Astro, the Pittsburgh-based lunar lander company, but today he's employed in Pittsburgh's thriving robotics industry. Some fun facts about Dan outside of college is that he has 300 skydiving attempts and 50 paragliding hours. Welcome to the podcast.
Hey, thanks for having me. I'm excited to be here.
Hey, Sam, glad to be here. We all could use a little bit more space in our lives, so always happy to be here talking about humanity's future in Mars and beyond.
Hey, Sam, thanks for having me. It's great to be here, and I'm excited. How are the microstates and macrostates treating you nowadays?
Yeah, very well. Thanks for asking.
Yeah.
Just to start off, I have to say that I am very excited about this show. This subject can be such a rabbit hole because this is the present and future of not only space exploration, but for the entirety of the STEM fields, which is science, technology, engineering, and mathematics. So as a short history lesson, Mars exploration attempts began as early as the 1960s, with the USSR and the USA working to send probes to take flyby imagery in an attempt to confirm Mars' atmospheric composition, temperature, and pressure. So Mars exploration actually slowed after 1975, but then picked back up in the early 1990s with big names such as Pathfinder, Spirit and Opportunity, Curiosity, and now the most recent and active, Perseverance. The true cornerstone came when President Barack Obama in 2010 addressed the direction of space exploration in the 21st century. This marked the slow efforts of lunar exploration and shifted the efforts of the science community in an attempt to get humans to Mars. So mission by mission, NASA, along with third-party and global efforts, continue to learn and progress technologies for the long-term goal of colonizing Mars. So when we come back from our first commercial break, we will discuss the challenges to be faced in the attempt to colonize Mars. Stay tuned. Woke Talk Podcast utilizes Anchor by Spotify to broadcast and supply our content to other third-party platforms with absolute ease. If you, the listener, are thinking about starting your own podcast like Woke Talk, we highly recommend you check out Anchor by Spotify. Their creation tools allow you to record and edit your podcast right from your phone or computer. Anchor will also distribute your podcast for you so that you can be heard on Spotify, Apple Podcasts, and much more. You can make money on your podcast with no minimum listenership, and one more thing, it's absolutely free. So download the free Anchor app or go to anchor.fm to get started. Welcome back to the first topic of Mars colonization, good or waste, where we will discuss the challenges that are to be faced moving forward in an attempt to place humans on Mars. With that being said, I would like to go to Gabby, where she can portray her thoughts on Martian settlement.
There's a lot of different things about getting to Mars that might put a damper in getting to Mars, or if there's more technology development in the future, it might be a positive thing. I know that the travel time to get to Mars is anywhere from 6 to 7 months. And that's a pretty good chunk of time to try to get out there. Maybe in the future, if there could be a faster way to get out there, that might be a plus. But as of right now, that's what the technology allows us to do. It's also very particular how to get out there because we want to use the most energy efficient way to get to Mars. And that depends a lot on the planet's alignments. There's a window of when Mars and Earth are closest together in their orbits that we can launch a rocket from Earth and it'll follow Mars's orbit parallel and then it'll perpendicularly hit Mars. That's whenever the planets start to drift a little farther apart, but if we get them to launch when they're right next to each other, it's the easiest way and the most energy efficient way to do that. However, the only time that happens is once around every 26 months. So it's a really, really small window to get that alignment. So there's a lot of things that are involved and a lot of conditions that need to be met to launch to go to Mars. So it's not like we can go ahead and just go to Mars whenever we want. We have to wait until the conditions are perfect to get there. And then we have to make sure that we have 7 months of time to send people or equipment or anything to the planet.
Right. And that's effectively because the Martian year is roughly 687 Earth days.
Yeah,
It's
a lot longer.
right. It's a 2-year rotation rather than a 1 Earth year rotation. So it's an extremely complex problem. It's not just like you're going to get in a rocket and drive in a straight line. You have to think about your weight in terms of your fuel, how many people you're bringing, what you have to bring in terms of test equipment. And then every time you take a piece of equipment off, you have to reassess your trajectory. It's not going to be the same.
Yeah, you have to make sure that like your rocket can get up to speed with the weight that it has, that it can get through the Earth's atmosphere, which is a huge thing, which, yeah, they've done really well, but you have to make sure with Mars's atmosphere that you can land without crashing into the planet as well.
Right. Now, I wonder, do you think they would ever consider in the future using the moon as like a slingshot, like whenever they do long distance trips? Maybe that might be a viable option.
Yeah, I think that they could. I think, again, it depends on the planet's positions. So I think if they were going to use it as a slingshot, they might want to wait until the planet's further away for landing.
Right.
You don't want to do a short distance trip with a higher velocity.
Right.
You're saving in that sense as well. So using the moon as a slingshot would save a lot of energy for the rocket. You could probably send heavier equipment up and stuff too if you do that.
Absolutely. Yeah, like you said, it's just the most effective trajectory that has to be used in that time frame. And missing it by a day or two can
You could miss the entire planet.
exactly. Now walk me through this. When you get to Mars, what's the atmosphere like?
The Mars atmosphere is super, super thin. So a lot thinner than Earth's atmosphere. It's pretty much got no nitrogen at all. It's like more than 95% carbon dioxide and less than 1% oxygen. Not much going on there.
Right. And also they have a decent amount of water vapor. That's probably maybe its third most component, which isn't a lot. I mean, we're only thinking about 1% of the Earth's atmospheric pressure on Mars.
Which is interesting because since the atmosphere is so thin, you're getting a lot of radiation from space coming onto your planet too. You know, the Earth protects us from that a lot with its heavier atmosphere.
Right. And because Mars doesn't have a magnetosphere, it's the solar winds from the sun is actually taking away roughly a kilogram of the atmosphere every second.
Yeah.
So it's continuing to wean off. It's not like it's just stagnant at 1%. It's going to continue to keep being eaten away until there's nothing.
Yeah, I mean, the solar winds, radiation, just pretty much anything that we're protected from Earth isn't protected from on Mars. It's not very, very welcoming.
No. Well, since the atmosphere is so thin, what are we talking about in terms of temperature?
So it can get up to 70 degrees Fahrenheit normally, but it's usually cold. It's usually I saw anywhere from -80 to -200 degrees Fahrenheit because, I mean, it's not trapping any heat because there's no atmosphere to trap that heat in. It's very, very cold.
Yeah, and for you SI fans out there, that's actually -63 degrees Celsius. So it's it's not like you're gonna walk outside in just a regular LL Bean coat and think that you're gonna be okay. Might have to wear a couple LL Bean coats underneath the spacesuit.
Yeah, I was actually kind of shocked at how cold it gets up there. All the water's frozen.
Right. There's no greenhouse gas effect. It's really small because you're dealing with 1% of the atmospheric pressure of the Earth. So you have no albedo, and an albedo is pretty much whenever the sun's solar rays comes into an atmosphere and hits the ground, there's a increase of reflection. So the thing with Mars is its albedo is so large that it just reflects it right back out without getting trapped by greenhouse gas.
Yeah, everything just reflects right off that soil and just goes right back into space. Nothing gets trapped. No heat gets trapped. There's no thermal effect on the planet at all.
Right. And speaking of soil, I know you studied a good bit of chemistry. Can you take me through like what's the regolith made of on Mars?
So it does get that rusty and red color from the iron oxide that's in the soil. So instead of being called the red planet, it's more like the rusty planet. But other than that, the big difference of the soil on Mars and the soil on Earth is that there's no organic matter in the soil. And organic matter is what plants use to grow. So looking forward in that, there's not much you can do crop-wise in that sense. There's a lot of perchlorates in the soil. Perchlorates, iron oxide, and then underneath all that dust is just the like volcanic like basalt. So it's just a lot of like sodium and chloride, magnesium, potassium, nutrients.
Right. There's a lot of salt on Mars. One of the most common rocks on Mars is basalts.
Because of all the volcanoes and the craters.
Right.
Like that dust layer is made up of like the iron oxide, a lot of the perchlorates, the sodium, the potassium, magnesium, and then under that is just volcanic rock.
Yeah. I'd be curious how much effort and energy it would take just to grow a potato. I know when I was younger, I read The Martian by Andy Weir, and then just the sheer effort that he had to go through in terms of just trying to plant a few potatoes was insane.
Yeah. I mean, if you think about all the things that we just talked about, it's cold, so you have to figure out how to build a greenhouse that houses the atmosphere that you need to grow a potato and to contain the temperature, which is that like thermal balance between the inside of the greenhouse and the cold temperature outside. It would take a lot of effort.
Right. And I think that's something that's taken for granted of here because we're so used to having rich soil.
Yeah, it's definitely not something that you think about with a lot of the other planets in the solar system, but particularly Mars, since that's who we're looking at for future colonization.
Right. Well, thanks, Gabby. Now let's move over to Dustin, where he can discuss the challenges we will have to overcome. So, how about we start off with your thoughts on radiation?
Yeah, okay, thanks, Sam. A lot of people say Mars is hard, right? So there's a lot of hard challenges, but I think we have, a lot of smart people working hard on it. And we've been studying Mars for like 40 years now with different orbiters and landers and things like that. And so I think most of these problems we're going to discuss are what I call like, I think they're solvable. And I think we're going to have it figured out here in the next probably 15 years, which is really exciting. So with the problem of radiation, you have a lot going on there. So one thing, Mars has no magnetosphere. So its core doesn't have any molten rock currents. The Earth has this liquid inner layers, and we can have, as we understand it, basically there's it's called the dynamo effect, and there's some currents flowing, and that produces our Earth's magnetic field, our magnetosphere that protects us from what's called the solar wind from the sun. And so our sun is always producing a lot of radiation and it throws it out in all directions in space. And so it has no magnetosphere and it has very little atmosphere. Okay. And so our atmosphere serves a lot to protect us from UV radiation and things like that.
Right. In terms of the UV radiation, I read that on the surface of Mars at the equatorial region, you can get bombarded by 2,000 times the ultraviolet radiation that you would receive on the hottest beach on Earth. So ultimately, you took your spacesuit off for some reason. Not only are you going to get destroyed by the vacuum of space, but also get cooked.
Yeah, that's a sunburn you don't want. There's these occasional ejections from the sun called coronal mass ejections. The sun can just throw out a huge amount of like plasma, sun material, and you have a lot of charged particles traveling out there. They're very damaging. And so, I mean, it can kill whoever goes there first, basically the first people on Mars or in transit or something, if you don't have adequate shielding and things like that.
Right. Just to back up real quick, the reason why Mars doesn't have a magnetosphere or a magnetic field to protect the planet from this radiation, just 600 million years into its existence, it ended up hardening its core. So it's actually been lost, the magnetic field, for about 4.2 billion years now. And the solar winds, then, what it does is it has an effect called sputtering on the atmosphere, where photons will come and ionize particles in the atmosphere. It'll deflect the ions then into space and be lost forever. So it's a slow nitpicking of the atmosphere down to where it is today. Back then, it used to be, like as Gabby was saying, a lot greater than what it is now. And that's why you would get excess radiation on Mars. There's nothing to protect you whatsoever.
Yeah. And so we'll need some type of ideas to help with that. I was reading somewhere that some ideas were, I think, a 3D printer up there to take the Mars soil or regolith and use that to make bricks that'll have shielding. I also guess water and then maybe like some organic material with water in there too is a pretty good source for shielding. So you can like maybe have a layer of water or press some plants into a brick or make like a layer of Mars soil material, and that might help.
Right, it's pretty much an unfired brick. We do that even in construction here on Earth. But so speaking of water, I mean, where is the water on Mars?
Yeah, so there's water on Mars, and there's a small, tiny amount as water vapor in its atmosphere, and there's not really a practical source for water, but there's a lot of frozen water on Mars. And so, like the southern pole is covered by an ice cap, and it's actually water ice. And during like the winter down there, you get a layer of CO2 ice. It gets cold enough that CO2 will form ice, and you get a meter or two of CO2, but then you have a lot of water ice under that.
Isn't that a permafrost, if I'm not mistaken?
Yeah, I think it's like a permafrost type thing down there that you can have layers of like dust, water, and then like frozen CO2. There is frozen water there, but it's not just at the South Pole. I think they found it other places as well under the surface. And I think if they drill through the soil, they're detecting that they could find solid water there. And recently, they just found for some radar studies that it looks like there's liquid water near the South Pole. And so they're thinking there's subglacial lakes or underground lakes. They think maybe there is some liquid water under there, but then no one knows what the heat source would be. So maybe it's really salty. And then they figure out maybe it's like a slush with like dust and dirt and salt. And there's just like some liquid water in there with it.
That makes sense. It's protecting it from that radiation. And I think that's why you're seeing a permafrost rather than just seeing ice on top at the poles. Because without that shielding, you would just have all water vapor because it would automatically sublime or sublimation, where it's sublimation is the transition between ice to a gas, if I'm correct.
Yeah. Any solid phase to a gas phase.
Right.
The exciting thing is there's water there. A lot of it's frozen as solid. Maybe there's liquid, we're not sure. And then the exciting thing about liquid water is it could harbor life because we have like subglacial lakes here on Earth that we find, bacterial life and things in. But the big thing with water, of course, is that you will need to drink it, right? So we need maybe for chemical processing, that and the CO2 in the atmosphere we can use to make things like O2 and methane, which we can use for rocket fuel. And hydrogen, we can make hydrogen out of that.
Yeah, even just using it for heating.
Oh, yeah.
Methane's a great way to produce heat. I mean, you're creating chemical reactions, so one of the things for chemical reaction is creating heat. So, yeah, using that as rocket fuel or energy heating these microclimates that we're going to need is absolutely important. I think that's why NASA's number one goal, finding water deposits, and they already are, which is fantastic. So the next thing I thought would be interesting to talk about then is Mars' gravitational situation.
Right. So it has 38% of the gravity of Earth. And so it's not like you're on the ISS and you're just kind of floating around all the time. But I think on the other, so we have some gravity on Mars, so that's good. And it's 40% of Earth, so that's, not nothing. And then the thing is, though, people will be there longer. And you have the spaceship transit, where they are going to be probably weightless unless we do something else, like make some artificial gravity for the trips. For, if the space shuttle that takes us there and then returns us. One thing is you could have like a spinning region, and from the centripetal acceleration as that spins, centrifugal really, then your astronauts will experience that acceleration, and so you can even mimic a full G if they're in that rotating segment.
Right. That's vital if you can do that because I got to remind everyone that Mars is on average 49 million miles away from Earth in its planetary orbit. So being able to mimic some sort of G-force to help out these astronauts, these travelers, whatever it may be, it's paramount. You need to have that to promote their health in the long term.
Yeah.
Everyone's so used to these quote unquote short trips to the moon or to the ISS, but this is just a whole new level of challenging in terms of having some sort of G-force for these people. You have a 6 to 8 month trip and then probably another year's stay and then another 6 to 8 months back. It's about 2 years.
Yeah.
So just as Gabby was saying, if you leave at a certain point, you have 2 years no matter what.
Yeah. Right. Yeah, you can't decide to go back. But the and it's neat because the people that go there first, they're going to be guinea pigs in a lot of ways. And one way is the gravity. Like, what's the end effect of 40% gravity on a person for a year? And we're going to have some case studies of that.
Oh, absolutely. It has major effects to your blood vessels, your arteries. There's a lot of long-lasting effects to this. You lose your muscle density. There's more past than what the eye can see in terms of health effects. Not even just talking about the radiation with cancer in the long term, but thinking about the G-force in terms of what it does to your muscles is significant. That's why people on the ISS have to work out almost constantly.
Yeah.
And then I wanted to touch on one more thing. I know we talked about this offset, and that's kind of the struggles of energy. Everybody goes to think, oh, we should try solar power first. But it's only most effective whenever you're placing solar power at the equatorial region of Mars. Because even if you are at the equator on Mars, you will only get 60% of the power you would on Earth
Neat.
on average. Mars is the fourth planet from the sun. And like I said, that's an extra 49 million miles that you need light waves to travel. And you have a major drop in reduction. So you're going to need more
Right.
of the solar panels to suffice that energy need that you would on Earth. And on top of that, you have to get all of the components there to provide the necessary power for sustaining life. And even more so, it becomes a liability to clean because humans, they have to go out and clean these all the times because of these massive dust storms, or you have to be able to have the AI robots to do it.
Yeah. I read there's a lot of dust devils on Mars. And so one of the rovers, its panels kept getting covered with dust, but then like they'd find suddenly the next day that like it was completely clean again. And it was from these dust devils on Mars coming by and like helping it out now and then.
Right. Oh, and I forgot. If you're in the equatorial region trying to make solar power because you want to maximize your output and you have water more towards the polar caps, which do you choose? So do you choose less energy, more water, or do you choose, more energy, less water? See, I would go with putting the solar power up closer to the poles. That way you can have solar power, possibly wind energy, and then on top of that, hydrolysis.
I really assume that the first place we land with humans to like set up will be relatively close to some type of known water that they can access. And they'll have to get so much to use, and they'll have to recycle that water. And one other thing I wanted to talk about was, thinking about food. I think food's something we have to take it with us. There's nothing there, of course. And I think the jury's still out on just how conducive the Martian soil is to farming. There's like chlorine and things called perchlorates in the soil that are toxic. And yeah, I'm not sure farming will be a thing that immediately happens unless we bring our own soil and have like indoor little farms. And so assuming that most of the food will be like freeze dried stuff or, something like that, that they take with them.
And that's kind of circling back to the atmospheric problems is Mars doesn't have any nitrogen. And what's important to the food cycle, making food? Nitrogen.
Oh, okay.
And the perchlorates and everything that's packed into the regolith, it's going to be a large feat to be able to farm that soil. The best way to go about it is just creating a microclimate,
Yeah.
and or bringing your own potting soil. But as we know, the more weight you add, the substitutes that you have to make for other technological research when you're there. So you have to weigh and measure.
Yeah. There's something I forgot is we drill into Mars now, but I guess we only drill like 6 to 15 centimeters. And even just by drilling like through the very top layer and then down, we get out of where it's just the red planet and you can get like gray soils and different things like that. But I'm thinking maybe we can dig deep enough to get to some vital molecules and minerals for life just by getting the human element there to dig down deep enough to find it.
That's absolutely right. I know that's on NASA's agenda, that as soon as we get there, that's what they want to do. They want to drill, they want to take core samples. They already have core samples, but you're right. It's only so deep right now with the rovers that we have.
Right.
But I do agree, just to get there and have some sort of handheld auger or a shovel and then take that back is going to be monumental. Who knows what's a foot down?
Yeah.
And I think that's vital to the progression of colonizing Mars someday. But thanks, Dustin. That was well said. To round out the segment on challenges to be faced, we want to finish with Dan, where he will provide the technological hurdles we will encounter along the way.
So, like we've heard, Mars is a pretty rough place. I mean, it's colder than hell, and it doesn't provide hardly any of the protection that we see here on Earth. The surface is just blasted with radiation, both electromagnetic and also particle radiation. And so the first technological hurdle is how do we shield and protect the human body in space? And there's only really two ways that people have proposed to do that. Number one, and maybe the easiest way, is to let the environment protect us where it can. And what I mean by that is finding caves, finding places on the surface of wherever we're trying to go and get people underneath the surface to shield them from toxic radiation. The Apollo astronauts, when they were on the moon, they were at risk. If there had been a solar flare in the right direction at the right time, they would have been essentially helpless and they would have been fried by the radiation. So finding caves would be a great solution. And the other is to build places to habitate and live. And the way that people want to do that is to send robotic explorers and robotic builders to go and build our settlements. There's been work by the European Space Agency to develop robots that can act as bulldozers and backhoes and actually pile on regolith, the material on the surface of these of the moon and Mars, and pile it onto pre-built houses. And by piling on that extra dirt, that's more mass that we don't have to take ourselves to the surface of Mars. And by doing that, we can build up shielding wherever we end up living. We aren't just confined to the caves.
I actually read something just the other day. There are third-party companies out there that are looking into 3D printing habitats on Mars with the regolith. which is kind of interesting. I think that'll be a quicker solution.
Right. As far as the structure goes and the insulation goes, being able to do that would be fantastic. And yeah, and 3D printing is a great way to throw in a buzzword and double the value of your company as you're trying to sell it. You know, solving this problem of how do we shield people from the radiation, that's definitely our top priority in terms of it's one of the top problems that needs to be solved. Another is keeping people safe from the vacuum, because Mars, even though it does have an atmosphere, it's a lot closer to being a vacuum than it is to being the pressure we experience on the surface of Earth. So figuring out how to keep an ample supply of atmosphere everywhere that people want to go and doing it redundantly. You see a lot of the designs when you see the concept art and designs for even the rovers that people might drive on Mars. You see a lot of them are enclosed, and a lot of them are like a car, but they have to be a lot beefier to keep an atmosphere inside of them, because you're always going to need redundancy and keeping your atmosphere from depressurization. There's been some incidents actually here on Earth that are kind of like what people will face on Mars. Deep sea divers, when they go and work for weeks at a time well below the surface, the time it would take for them to decompress as these divers are coming up from the surface, it takes too much time over the course of the day, that it's just more feasible for them to stay at a high pressure. And so instead of being brought up to the surface, they get into a pressure chamber at depth, and then they're brought up and they stay at that high ocean pressure, and they're able to live and work in this higher pressure. But there's been some horrific incidents of them accidentally decompressing, and it's just this incredibly violent moment that killed everyone that was involved. So if you're trying to live for a long time out in that near vacuum of Mars, it's really paramount to have a redundant way to stay pressurized.
Yeah, I would say that it is important to kind of address the elephant in the room when first talking about something like this, because along with battling climate change, this is practically the biggest scientific feat we'll have to face in the 21st century if we move forward with it, and will more than likely extend into the way foreseeable future. This is no walk in the park, and I think my guest stars pointed that out. There are major health effects, biological effects, energy hurdles, you name it. What is wonderful about science is that it brings humanity together, because in order to tackle these complex problems, you need ideas coming from all angles. And when we come back from this commercial break, the cast and myself will uncover some of the legitimate ideas tossed around in the science community. Woke Talk Podcast would like to acknowledge Tree Cup Tea for their delicious organic tea and their cause for reforesting the island of Haiti. At the start of 2006, Haiti was stripped of 80% of their forests due to agricultural malpractice. Because of their partnership with Haiti Friends, a non-profit tree planting organization, Tree Cup Tea's goal is to fully restore Haiti's forests by 2030 and continue to support reforestation worldwide. Tree Cup Tea sells 4 different flavors of tea that can be bought by the 12-pack and delivered right to your door. With every purchase, 12 trees will be planted in Haiti, along with a supply of 12 complimentary maple tree seeds that can be planted in your very own neighborhood. To learn more about their cause, operations, and tea, go to www.treecuptea.com or follow Woke Talk Podcast on social media platforms such as Instagram, Facebook, and Twitter to find Tree Cup Tea's official link. Just remember, Tree Cup Tea uses your contributions of buying their tea to plant a beautiful tree. And we are back here at Woke Talk Podcast. I am your host, Sam Stanford. Heading into our second segment, we want to talk about some of the actual ideas that the science community has proposed to colonize Mars. With that being said, I'd like to hand it over to Dustin, where he can talk about what third-party companies have brought to the table.
All right, thanks, Sam. Yeah, so there's a lot of companies doing a lot with space. Okay, it's kind of the short of this. So it's very exciting. There's a lot of competition building for, hey, we can put your satellite in orbit, okay? Or, hey, we're going to be able to, slingshot you around the moon, or we're going to be able to take you to the moon someday. And then there's other companies and government agencies that are focusing on those things, but also getting us to Mars. So the big one that I wanted to talk about was SpaceX. And Elon set the mission for, hey, we're going to launch a crewed mission to Mars in 2035. Okay, so that's 14 years from now. Really exciting. China has come out and stated 2 years earlier that in 12 years from now, in 2033, they're going to be launching a crewed mission to Mars. So this is really heating up. So SpaceX is going to use something called the Starship. Okay, it's supposed to do a test flight here in July, and Starship has a lot of plans. The Starship is the thing that's going to take people places, and they also have a supply one that'll take cargo places. And there's a lot of goals for this. The Starship space shuttle system, there will be a planetary component that just takes you, or maybe an Earth component that takes you from anywhere on Earth to somewhere else on Earth. And it states it can get you there within 34 minutes because it launches you up into space. You go around the Earth and you land somewhere else. So if you want to go to Australia, maybe you're looking at like 35 minutes from from the launch pad.
I'm curious about what that is, like how much that is.
Oh, how much cost? Yeah. Well, that's right, but that's how it starts, right? Already we're getting into space tourism. And you can buy tickets to go, up into space right now. And more companies are getting there. And the Starship will also could take us to the moon and land on the moon. And the big goal is that this is the thing that's going to take a crew to Mars. It's all reusable parts. So you can have the crew goes on a Starship. And another big thing, is it refills in space. It refills in orbit. So it launches off the Earth, and then it has a tanker there that will refill it. So then it has fuel to go to Mars. Okay, so I think that really hits on, it doesn't just have to coast to Mars. Like, they could put enough fuel in space to, I assume, align the correct trajectory and have an accelerated trajectory, like we were talking about before, where it could even simulate some gravity then. And then that'll land on Mars. They could use the same one when they come home, or there could be one there waiting for them that's maybe already fueled, because whoever sends people to Mars will want there, whether it's an agency or a company or whatever, probably a combination of the two, right? Like NASA and SpaceX working together, they'll want to have supplies there already. So maybe we'll already have had working a system to make fuel on Mars, and it's already made all this fuel for the Starship rocket there that's going to wait to take the crew back home sometime. So this Starship thing is really game changing. That it has a first and second stage, and so I think it's the first stage that it's called heavy or super heavy, and it really gets you off the planet, and then it comes back and lands. I think the second stage is where the top half of this thing, and that's where the people or the cargo or whatever will be, and that's reusable as well. So that's really what we're going to need is reusable parts. It seems he has a goal to make them rapidly in the future, so that you're not waiting like to produce a rocket every 10 years or something like that. So you have these that they're ready for the missions you need them for. They're ready to go.
That's great. For the shuttle part, I'd say that it's perfect to get the word out there and to get more funding in different ways. So then you can do the things that truly matter.
Yeah.
Continuing to discover water deposits, or looking for life on Mars, or rebuilding the magnetosphere, whatever it may be.
Absolutely.
I think that's a great use of more funding to the projects.
Oh, yeah.
The one thing that blows me away about SpaceX is Elon's Twitter feed. And did you see whenever he tweeted 2 words, Nuke Mars? What do you think about that?
That, I think, like maybe you could warm the core up enough that you might get some more of this strong magnetic field back. And I think one idea was like setting nukes off inside of it. I don't know if you want to nuke a place you're going to try to then colonize. Is the short of it.
No. There was actually a study done back in 1997 by Zubram and McKay on the terraforming of Mars, where they concluded that to increase the temperature on Mars approximately by only 4 degrees Celsius through nuclear bombs, we would need 27 terawatts of power. That is equivalent to nuking the planet every 20 minutes for the next 50 years. Is it possible? Yeah, in a material standpoint, but is it financially viable? No. And I think that what Elon's doing isn't really to be outrageous. It's more or less to grab people's attention
Okay.
to the subject itself to inspire more people to come up with better, viable ideas and get people more into the funding mode.
Well, that's the thing. You can't like convey tone or like a tweet is just text, right? So you don't know exactly how he meant that, right? So it could be just like you said there.
Right. I don't think he really means that because he's also interested in finding life on Mars. I mean, all of SpaceX. I shouldn't even just single out Musk because he has a amazing board of advisors and stuff like that. But just to do something like that, it would probably destroy what we don't know before we even discover it. Just imagine if there's that microbial life under the permafrost and then you just blow it away. Yeah, there goes the idea of terraforming the natural way.
Well, and like if we're gonna try to terraform the planet, like long-term goal, I assume means we're gonna be able to build an atmosphere there. And then I think you're going to get some more trapped sunlight and you're going to get some warming of the surface just from, I think, having an atmosphere there.
Right. I'm more excited about the microclimate adjustments before we start terraforming the entirety, just because it's such a large scale feat. I would rather see us
Right.
trial by error that microclimate first.
Yeah, it's going to have to start with like little bubbles or something like that, you know?
Oh, absolutely. Oh, one thing that I wanted to talk about, I think we talked about this offset, a kind of system where you can create artificial gravity within the microclimate through taking these colonies and allowing a spin system.
Right. So it's an interesting point. Like, I always picture the spinning stations in space. But yeah, you could have something like spinning on Mars to generate some, maybe you go get your like hour of Earth gravity or something like that, you know?
Yeah, I think it would help balance the miss of gravity just to help people kind of stay
Yeah.
a little more healthy for a longer period of time. I also love the idea to take probes and put them out there and divert ammonia-rich comets. Just to circle back, we were talking about the scarcity or the idea of just only having food that you bring. If you divert these ammonia-rich comets, they'll impact on Mars, and then you could break them down because ammonia is NH3 into nitrogen and hydrogen and use that hydrogen for energy, but then use the nitrogen itself to then place into the soil. And hopefully, if you can separate the perchlorates and stuff that's in the soil, you can then get a terraformed soil to create food. So that's a really cool idea.
Yeah, that's a really cool idea.
Yeah, and then on the topic of probes, I came across a couple articles on large scale solar reflectors.
Oh, okay.
Yeah, to then warm the surface of Mars. I mean, you would need a lot of solar reflectors, but just hovering them in an orbit that they maximize the warming effect in your microclimate rather than trying to focus on heating the entire planet
Oh,
at once.
yeah.
That would be a more down the line progressed technological era. But I think taking advantage to develop a microclimate would be totally viable.
Yeah, that sounds more realistic for sure.
Absolutely.
So we've had some exciting news this year so far was that NASA has a program called the Artemis program. And this is a plan to land on the moon in the mid 2020s. And well, it's 2021, right? So I'm like, this is soon. And why am I not seeing this all over the news? But yeah, in late 2021, they're going to send their launch system in a test flight. And they have a mannequin. Actually, there's going to be three mannequins in the ship, but I think they named one the Moonikin. And it's a test of their flight system, and it's going to go around the moon and come back. And there's a 2024 date to put humans, and we're going to put them near the south pole of the moon in 2024. And then SpaceX is planning a flyby with people in 2023 using their Starship system, which is what the plan would be to get to Mars, would be the Starship system.
Fantastic.
Yeah, it's really exciting. And but there's been a lot of testing here on Earth of development, testing, and validation of new exploration techniques and strategies to go out into space. And so, there's places on Earth that they're like, this is kind of like Mars. And so let's put some people there, maybe isolate them and have them test these suits and things like that. So there's been a lot going on behind the scenes in preparing for Mars over a decent amount of time. And so that it feels like it's going to happen within like definitely 15 years, knock on wood.
Right. Those ideas are very interesting to say the least. And now I would like to transfer over to Dan where he can discuss NASA's plans moving forward.
Yeah, well, right now, NASA is currently working on exploration, the search for life, and of course, searching for water. Water is the most important resource in the solar system as far as it goes for humanity. Kind of the common saying is that you can drink it, you can breathe it, you can burn it. Obviously, it's water, you can drink it, but also it's 2 parts hydrogen, 1 part oxygen. And by splitting the water molecule apart, you can actually turn it into rocket fuel. Hydrogen and oxygen, you mix those together and you can actually burn them. And that's actually the rocket fuel used in a lot of rockets. And then, of course, you can also breathe it. You split the oxygen molecules apart, you bind the 2 oxygen molecules together, and you have oxygen you can breathe. So water really is the most important resource. It's what keeps humans alive. And if you have enough water, you can turn it into a gas station. So going forward, the search for water is always going to be a top priority for NASA. But right now, the exploration, a lot of it's happening through these amazing rovers. And now, as of this past month or two, their new helicopter that they have running on Mars. And the thing that really excites me about this, the ingenuity, or Ginny as they're calling it, the thing that really excites me about this helicopter is it's a departure from the way that most NASA operations have been going since the early 2000s, which is that everything needs to be perfect and everything needs to be redundant. The past 50, 60 years of spaceflight, if you don't have components that are highly redundant and flawless as possible, it leads to all these catastrophic effects. Well, now we're starting to see there's certain moments where NASA started to say it's okay to make things that aren't as redundant, aren't as radiation hardened, aren't space qualified components. And so this Ingenuity helicopters kind of made out of what they call COTS parts, which that's an acronym for Consumer Off-the-Shelf Components. Not all of it, but some of it is actually made using components built not for space, but for applications on Earth. And the fact that people have put in as much effort as they have into making these components, kind of retrofitting them for space, a lot of the software that runs on the Ingenuity helicopter comes from open source software. And so all these people who've been developing and contributing to open source software online, unexpectedly, they now have the privilege to say that some of their code actually runs in space, which is pretty exciting for the developers. And so this Ingenuity helicopter, it's now been doing missions even in the less than a percent of the Earth's atmosphere. This helicopter can still run, which is just mind blowing that, that they can actually fly such a thin atmosphere. Eventually, the autonomy systems will be developed far enough along to where people can let up the reins and let these craft drive themselves around, navigate around, and react much faster and ultimately get more work done. And when we can send up a fleet of vehicles able to actually do work on the surface of Mars and not require, a person to manually send the commands, manually send the missions, but can actually do the work themselves, and they don't all need their own slow data link. You might have heard of this. There's something called the 7 minutes of terror on Mars, which is when something big happens, like you're landing, you don't know about it for 7 minutes. You don't know how it went until 7 minutes after the fact, because usually the distance between Earth and Mars is 7 light minutes or 6 or 7 light minutes. And so, that huge delay really can slow down missions, especially on time sensitive things. So as robotics and autonomy, machine learning, artificial intelligence, as all of these different disciplines kind of culminate together, we're going to see a lot more of these vehicles being sent up. So they're working together in a group, in a team, and eventually be able to get a lot more done by doing so.
Yeah, that's really cool. I was doing some research and I ran into one of NASA's big ideas. They said in 2017 that they came up with an idea of a magnetic force field for Mars. I know we talked about in the episode about how Mars lost its magnetic field. And what they wanted to do is create a magnetic field at some point in space to protect it from the solar winds of the sun. And that's necessary to cause, a large enough diversion. So you have to make sure you're at the appropriate middle point and make sure that the shield moves in sequence with Mars as it goes around. And ultimately, what it would do is simulate the same sequence here on Earth with our magnetic field that causes, if anybody has ever seen of the auroras, that's exactly what they're trying to simulate.
Who knows what we'll be able to do, but that sounds like the kind of moonshot thinking that people need to have whenever facing these grand challenges of humanity's future in space.
It does take sometimes these abstract ideas to get people extremely interested and extremely involved in propelling us into the future for Mars exploration.
I like how you put that. We're living in science fiction today. Of course, when science fiction really gets it right based off of reality, it can do a pretty amazing job at predicting the kind of future that we're going to create.
Right. Thanks, Dan. That was very informative. We will now round out the segment with Gabby, where she will talk about some of the global efforts in making dreams become a reality.
So I know that there are a lot of different countries trying to get to Mars as well. It's not just NASA and SpaceX trying to get up there. I know like last summer around June, a couple other countries wanted to hop on that. Let's go to Mars. And there was like the United Arab Emirates, which is like the first Arab country to try to go to Mars. And so, they're another country that jumped on that train to try to get people to Mars. I know China's been doing a lot of stuff to get to Mars. And then there's all the technological advancements that are going around the world that are trying to get people to Mars. So we talked about before in topic 1 about the travel time and how they're trying to make efforts to reduce that travel time or reduce the energy needed to get there, which is also, there's that idea of the space elevator being thrown around.
Right. So a organization in Japan called JAXA, JAXA, if you want to look this up, whoever's listening, they have concepts of a space elevator. And a space elevator isn't exactly what you're thinking. So the elevator would theoretically run from the surface of the Earth to a platform orbiting the Earth, just as the International Space Station does. And I've heard 2 scenarios so far just through my own research. And one where the elevator and the shuttle platform are tethered to the Earth. And the other is when the platform is untethered, just like how the ISS is working now. And I'll go over the tethered one for it being a little more interesting of the 2 situations. And this proves to be difficult yet doable. They would have to build this from the top down and not from the bottom up. So the platform would have to sit in a area called a Goldilocks zone between the pull of gravity and the centrifugal force acting on it from rotating around the Earth. So to obtain the most optimal takeoff, this space elevator would have to take place on the equator where the rotational speed of the Earth is at its highest, which is actually 1,000 miles per hour because we're 24,000 miles thick and it takes 24 hours to go around one time. So when you sit down and do the math, which I've done, the Goldilocks zone, this is the cool part, is 36,000 kilometers or roughly 22,000 miles from the surface of the Earth. So there's a lot of things at play here with the mass, counterweights, influences on other gravitational bodies like the moon or the sun. And with the right material technology, it could work. Possibly using substances like Kevlar or carbon fiber. I know the biggest one is carbon nanotubes, of how strong and small it can be because it's nano in structure, and it would provide our strength requirements.
The material would need to be like really light but really strong because you don't want it to have any like extreme stresses.
Right. If you're sitting in the equatorial region of the Earth, the first thing that comes to my mind is hurricanes. And you have to be able to withstand absolutely asinine strong winds. As soon as the tether would break, the counterweight would either retract immediately or that bad boy is coming towards Earth. So it's tricky, but I'm saying it's doable. I mean, it's just, like I said, it takes time and it takes careful calculations, but it's possible.
Yeah, I mean, it would probably even have like financial benefits if you think about it. And like you could move cargo up and down a space elevator. So then companies and stuff could like, send their stuff to space, and there'd be a lot of financial benefits from that, sending people cargo, supplies, food.
Right. And it doesn't have to extend to Mars. It can extend practically anywhere. I mean, you're up there in this Goldilocks zone. You have such a small gravitational attraction. So you can literally just take off and go so much farther with so much more fuel because you're saving so much instead of having to escape Earth's atmosphere. It'll probably cut the trip to Mars, I would say, in half.
You wouldn't have to worry as much about like energy conservation. I mean, you still don't want to try to send stuff in a space elevator to Mars when it's at its furthest orbit point from Earth. It wouldn't be as constricted. You wouldn't have to wait every 26 months for the planets to be in line.
Right. I know what you're thinking when you hear all these ideas, and they do seem kind of like science fiction, but I will say that science fiction writers are ambitious writers dreaming of futuristic possibilities. And science fiction ideas inspire people within the science community to make dreams become a reality. In a day-to-day conversation, we may assume that a space elevator sounds silly, but is it really that silly? The ideas in books written by Ray Bradbury and Andy Weir, as I called upon earlier, are becoming a reality today when they were written a decade, 2 decades, 3, 4, whatever it may be. So the ideas discussed in this episode can lead us to new discoveries and benefits that will be exposed when we come back after these messages. Woke Talk Podcast would like to promote Elite Graphics for their screen printing, embroidery, decals, graphic design, and much more. They also showcase their own clothing line on their website and currently provide free shipping for purchases over $50. Now, I've personally had them print custom t-shirts for me in the past, and I was more than pleased with the results and customer service. So with that being said, Woke Talk Podcast will utilize Elite Graphics in the future to make all of our merchandise. So if you're interested in getting some custom clothing, decals, or signs made, check out Elite Graphics at www.elitegraphics.org, and you can also find them on social media such as Facebook and Instagram, where you can see their past products, merchandise drops, and promotions. So contact Elite Graphics today, and don't just settle on being average, be elite. Welcome back to the last segment on the colonization of Mars, good or waste. This last segment focuses on the benefits of colonization and the continued exploration of Mars. I would like to then direct the conversation to Dustin, where he can talk about some benefits that should come from all this.
All right, thanks, Sam. So the benefits of this mission, I think there's a lot. I think maybe at the heart of it is that humanity, like our whole history on this planet, is of us exploring, moving to new places, and settling those new places. So we have some natural drive to explore and discover. And even, in very dangerous situations, like think about the polar explorers and what they had to, like that was a very dangerous mission to go on if you wanted to go out into the unknown ice. And so just to satisfy our own curiosity and to get out there and keep exploring our universe. So that's one big thing. Another benefit is we're going to learn a lot, I think, when we go to Mars. We're going to learn a lot about Mars and its geologic past, its evolution as a planet, but that also is going to give us an insight into the history of our entire solar system. because Mars, there's no tectonic activity on Mars. So Mars doesn't have, active earthquakes happening. The surface isn't resurfacing as via plate tectonics. The main thing is wind erosion, but there's not been any water erosion since the water on Mars evaporated off. Okay. And so we can kind of check out a past bit of our solar system that's hanging around today. And in terms of like sustainability, there's the idea like this could be a future home for us, maybe, or at least some part of humanity. And we can make use of the resources on Mars. So there's a lot of different elements on Mars. So this is stuff that we could start making use of, partly to build the colony and build things on Mars, but maybe even to ship back to Earth and have some type of little operation going on.
And then on top of that, I think Mars gives us a forecast on what the Earth could be if we, for say, lost our magnetosphere or had the adverse effects of climate change. And just gathering that information from these missions, then we could bring that back to Earth and explain to the people outside of the operation why this occurred, and then they might reflect or think about maybe what we do on our day to day isn't probably the best for the earth. Maybe they'll have a case study to say, wow, we really need to change, that way we don't end up like that. We don't need to be put in an adverse situation. So it's a benefit, I think, in that sense for sustainability, because we'll have to look out for the future generations after uncovering a lot of the information on what happened to Mars.
Yeah, completely agree.
I think you hit the nail on the head about saying that humans are driven by their curiosity. I mean, for the listeners at home, what do you do when you're in bed at night, it's pitch black, and you hear a noise? Your mind goes crazy. You're thinking of the unknown. You're fearful, but you're curious. What could it be? And I think that's the same way, because we have been so sheltered here in the hindsight of being humans. It's been so long that we haven't looked outside or into the dark. And I think taking the steps in going to Mars is going to get us out of our comfort zone.
Yeah, I think it'll be very exciting to see us become like a multiplanetary species, and yeah, interplanetary travelers. And hopefully, when I'm older, I could somehow maybe book a little trip to Mars or something. Like Gramps is going to Mars, grandkids. See ya.
I'm right there with you. Thanks, Dustin. Now I'd like to elaborate a little bit more about the societal and sustainable benefits that result from these efforts. So, firstly, without the total destruction of Mars from comets and nuclear bombardments, it is possible that we could still discover microbial life on Mars, which would allow studies to detect whether there is any relation between Earth's and Mars microbial life. If Earth and Mars have similar species of microbial life, that could suggest how the early solar system formed, and quite possibly prove that life can sustain in the harshest of environments, such as Mars, or even more distant celestial bodies such as Jupiter's moon Europa and Saturn's moon Titan, that have shown to possess an atmosphere much better than Mars. Essentially, microbial life is a major building block in developing complex life forms. And we know that through the evolution of life on Earth. And to continue this exploration is monumental in the overall expansion of our species. Secondly, Planet B. This seems like a more drastic reason for colonization, not just because of climate change, but because of asteroid strikes anywhere venturing through our solar system. Since 1998, NASA has set out to discover near-Earth misses of asteroids moving past our planet, and so far, they have witnessed nearly 25,000 of them. Having a backup plan to climate change and catastrophic impacts should and will be the way of the future to avoid extinction. And moving on, I also look at this as an experiment in the progression of fixing Earth with geoengineering techniques. Learning how to terraform, build water deposits, change temporal climates, or block solar winds would only help us fix Earth in the foreseeable future. Just having a better understanding of how Mars lost its molten magnetic core, vast seas, and early signs of life can pay dividends for our future generations. Even if Mars is a failure due to its sheer heights of difficulty, we know there are other celestial bodies at a greater distance with atmospheres that could use less work to terraform. So we can use Mars as a step in the right direction, primarily as a learning tool. And I cannot stress this enough that science is progress through learned failures. And finally, technological advancements. AI and robotics will continue to perform, progress, and learn mundane human tasks such as cleaning solar panels, extracting core samples, testing for microbial life, and much more that can only get better through adverse situations like being on Mars. I also think life sustaining technology will come a long way to protect humans from excess radiation and especially the non existent atmosphere of Mars by providing in situ oxygen for breathing. This is something NASA is currently working on with MOXIE, or the Mars Oxygen In Situ Resource Utilization Experiment, that converts carbon dioxide into oxygen on Mars. And MOXIE is currently working on the Perseverance mission right now. So, just to cap it off, there will be enhanced technology in so many realms that it is so hard to cover all of them in this segment. But if you have any inquiries, please feel free to reach out to us at woketalkpodcast@gmail.com or reach out to us on social media. I'd be happy to have any sort of discussion with you. So, finally, I would like to wrap up with Dan's thoughts on whether or not Mars is truly the celestial body we should be focusing on.
So when discussing Mars, I think it's also worthwhile to actually look into what's the right destination, what's the right goal for us right now. Mars obviously has the benefit of being the more impressive endeavor. No one's ever done it before. It's further away. It's very different from the moon in a lot of ways, but practically, it depends on what your goal is. And if your goal is to get people living off the Earth and living somewhere else in the solar system, I think it's worthwhile looking into the moon and really being sure you want to go for Mars before discounting the moon itself. The moon, in a lot of ways, is our sandbox for the universe. It's an inhospitable place, a place that people just cannot live without a lot of technology, a lot of shielding, and a lot of innovation. And Mars is the same. It just costs 10 times more to get a lot of those same challenges. The fuel costs are so much higher. The time it takes to get there, so much higher. But the moon has a lot of the same benefits. The gravity is lower than Mars, but it's not that much lower. The atmosphere is thinner, but as far as a person is concerned, as far as, a human being standing on the surface, there's not too much of a difference as far as I'm concerned between the moon and Mars. I see the Martian atmosphere as being more like the moon's atmosphere than more like the Earth's atmosphere in a lot of ways, and practical ways for a person standing there. But really, the fact that the moon is so close and just so challenging, it's kind of the perfect place for humanity to really work out all the kinks, really figure out the challenge, really figure out how to survive on another world without having to go halfway across the solar system to get there. I kind of appreciate NASA's current plan of, look, you want to get to Mars, use the moon as your stepping stone. Really work out what are you going to do, how you're going to do it, the technologies you need to figure out on the way. Do all of that on the moon. Build bases on and around the moon. Step up from our current achievement, which is the International Space Station, and apply what we've learned in the past 20 years of the ISS, apply that now to the moon. The most amazing part about human habitation off planet and off planet Earth is that now today there are people entering the workforce who've never lived a day in their life without people being in space. There are grown adults that are now of drinking age in the United States that actually, there have been people on the ISS perpetually since before they were born. And I think that's a pretty amazing achievement that we've been able to keep people living in space safely for that long.
Yeah, because you have to think about the motive. Do you want to live in a microclimate, or would you rather terraform an entire planet? If you're trying to live in microclimates, it's already more advantageous to be on the moon. Like you said, it's closer, there's more caves, it's so much more viable compared to having to travel all the way to Mars on, a 2-year trip rather than a few month trip. It's kind of tilted in that way. The only thing that scares me, that's a difference between Mars and the moon, is, as we talked about before, Mars doesn't have a molten core. And that's what caused the magnetic field to be lost. And with that, subsequently, you don't have volcanoes and you don't have earthquakes. The one thing that has been proven on the moon is that there are things called moonquakes. So as long as you can have a microclimate in a cave and be able to have the appropriate seismic design, I don't see why not. It's a lot more viable in that way.
I like how you brought up the caves. I mean, the caves of the moon are absolutely incredible. Because of the low gravity, there were lava tubes formed back in the day when the moon was still molten and still had lava on the surface. And these lava tubes, some of them are so big, you could pick up the city of Philadelphia and place them in the lava tube comfortably. That's how wide, that's how big around they are. And if we found one the right size, we could carve out a pretty big settlement and a pretty big space that's all totally pressurized. And here's one more thing. Here's what I would want more than anything, and what I look forward to the most about permanently colonizing the moon. The moon's gravity is so light that a human being with the right kind of physique, the right amount of physical fitness, and the right equipment, a human's arms are strong enough that if you wore wings that were the right size, a person is strong enough to fly like a bird through an atmosphere pressurized to what we have here on Earth. So if we can one day fill up a lava tube, put an atmosphere in it, close it off, and have a place where people can live there, people could actually fly with using nothing but the muscles of their own body. Human powered flight would be possible. It is possible today, just not on this planet, or not very long on this planet.
Yeah, it's all very promising. I would say I'm very excited about either one, whether it be the moon or Mars. You are correct where we should kind of maybe treat the moon as a stepping stone to some place a little bit farther away from the Earth. Let's just hypothetically throw out there that, our solar system is filled with many, many asteroids, and there may come a day where we have to kind of fly the coop. Wouldn't worry me, but it would worry generations of the future, is what happens if we come in contact with that asteroid. Per se, just a spitball, it hits the Earth, and then the big problem is, well, the moon and the Earth are in gravitational attraction. To keep exploring, I think it's advantageous to not only take over the moon as the human race, but also keep extending ourselves out there and making ourselves less viable to extinction.
Yeah, well, that's exciting to see, and only time will tell how it all plays out. It's just what makes space so enchanting, and why we always got to keep pursuing it and keep shooting for new goals and new dreams among the stars.
That is all for this episode of Woke Talk Podcast. I'd like to finish with a big shout out to the cast members for their fruitful and insightful content. We hope that our show not only provides you with more knowledge on the subject of Mars exploration, but also inspires you to dig deeper into the topics we discussed. Make sure to tune in next week for our 4th episode, Pro Small Business, where we will dive into the small business community and hear some firsthand accounts of the struggles and benefits to starting your own business. Thank you all for listening to Woke Talk Podcast. I am your host, Sam Stanford, and as always, stay woke. Woke Talk Podcast would like to give a shout out to Anchor by Spotify for sponsoring our podcast, along with Ben Sound Music for providing our show with intro, outro, and advertisement background rhythm.